Okay, so I'm live here with 52 weeks of Rust, episode 3. I was down for a couple weeks because I had a dislocated elbow from rock climbing. I fell about 12 or 13 feet, and it's not good on your elbow when you do that. So they had to pop it back in, but I'm feeling great again. I just couldn't type for a couple weeks, or I couldn't type well for a couple weeks, so I wanted to take a break. But I'm back, and now I'm going to cover more on Rust. And let's go ahead and share my screen here. Let's go ahead and get into this. Okay, so last time I believe where I was at was diving into the Rust language a little bit and getting into really just the basics, nothing too fancy. And I'm going to continue to go down that road of just uh, you know putting more and more documentation inside of here. I'm patient. I can take a long time to learn Rust, and we'll call this episode 3. And what I'll do as well is open this up inside of my favorite development environment, which is, I'm going to go ahead and configure this code space, is this GitHub code spaces. I really am a fan of it. It's now mainstream here, and I definitely would recommend playing around with GitHub code spaces. It's truly an awesome environment. Okay, so I've got GitHub code spaces cooking here, and I'm going to wait for this to open up. And then similarly, what I can do is look at the official Rust guide. Let's pull that up. We'll say Rust. Here we go. Rust language. Pull that up. There we go. And I believe what I was doing was going to read the book. Here we go. Yeah, let's go back to the Rust book. And I don't actually 100% remember exactly where I was, but I think functions potentially would be a fun one. I like functions. And so let's go ahead and start with this. So now that I've got this thing running, let's go ahead and take a look at how you build a function in Rust. So functions are prevalent in Rust code, which is awesome because I actually prefer to write in functions versus object-oriented code, just because I like the straightest line is between 2 points. And you already have seen one of the most important functions is the main. And if you use this fin word, it allows you to declare new functions. And Rust code uses snake case for function and variable names, which is letters are lowercase and underscore separate words. Okay, so this is nice because this is identical to Python. And so let's build this out. Let me just try to steal some of their code. And I'm going to put this inside of here. Not sure why that's taking so long. Let's there we go. So I'm back here. I'm going to just tweak this environment a little bit with GitHub code spaces and go to color theme. There we go, dark Visual Studio. And then I'm going to open up the terminal. Perfect. And now that I've got this thing ready, let's go ahead and let's create something called my func.rs, and let's just see what happens if I blindly paste that code from the tutorial inside. So we've got function, this is actually kind of similar to if I was going to write a hello world in Python, what I would do. So this looks good. Okay, so they say go ahead and run this, and well, we don't need the playground because I can run it myself. So I'm just going to say cargo run. Okay, let's go ahead and do that. Let's go over to cargo run. And cargo not found. Okay, well, I don't remember how to install Cargo. So let's go back here and, well, first let's see, do I even have Rust? After you installed Rust, let's see if this is even installed. Let's see if this works. Rust up. Oh, there we go. So I must have changed something so that Rust is not installed, which isn't bad. I can go ahead and follow the tutorial here, and maybe even put this into the documentation and say here, like installation will be helpful to people how to install. There we go. Go here. Always like documentation because you never know who will need it. There you go. You never can go wrong, for the most part, with documentation. It's always going to be helpful. So I'm going to go ahead and copy this command, paste this in. And why did that not work? It looks like maybe there's a missing. What is missing here? Let's just copy it without that. Let's try this. So curl, there we go. Downloading installer. Let's just do the defaults. When I don't know a language or a new tool, I never mess with defaults. When I was younger, I only messed with the defaults. So I think that's an experience thing. As you get older, you realize that you really don't want to mess with the defaults when you don't know what you're doing. Okay, so to configure your current shell, run that. Okay, well, we can do that. And I also can just edit my bash RC, and I'll just throw that in there. This is, there we go. So it looks like I did something here, but home cargo environments. So I think we basically have that already. So maybe I don't need to do anything. So let's go ahead and go to the next step, which is let's do Rust up. Let's just make sure we got everything working. There we go. I love this concept of a Rust up. That's great. I mean, I wish all languages had that. You just say update. So let's put that in a documentation and say, pro tip, run Rust up to update your installation. Now, that's cool. I love that. And what else do we need to do? We can look at the version. So there we go, Rust version. There we go. So I'll put that in there, like check version, do this, do this. Okay, great. This is great stuff. And okay, now if I go back to my shell here, and this is actually a pro tip a lot of students have had in Berkeley, Northwestern, Duke, UC Davis, University of North Carolina, all over the place. So, students in live trainings, they don't use history enough. And I would say it's absolutely one of the tools that's amazing to use. And so if we run history and we do less, look, I can be lazy and say, what was the thing that I was trying to do before that didn't work? Oh, right there, line 2. So I can just do this. I can do exclamation point 2, and I'll just rerun that line. Aha, could not find cargo 2ML in workspace 52 weeks of Rust. Aha, okay, so we're missing more stuff. Here's hello world. I see. So they want us to maybe make a projects directory. Let's see here. So hello world, open, make a project and directory. We cd into hello world. so in my case, I can just use the Rust compiler. So let's first try that. I'm probably needing to remember if well I don't even know if I knew this, but let's run it. Okay, so we compiled something, and we have a function in Rust, and we can say my function. There we go. So to compile, which again, since I don't know this, it's possible that people don't know this. I'll just say, this is like absolute beginners. How the heck do I compile? Okay, fortunately, it's not that bad. You just do this, right? You just say Rust, and we'll put a note here that says, in this case, the func. Well, let's even call. Let's do the kind of wildcard syntax here. Your file is what is compiled. Next, you run it. And I think that's how I run it, right? Did I do that? Yeah. So that's kind of clever. So you don't have to mod it or anything like you would do with a script. You can directly execute it. So the compiler must be doing some cool stuff there for you automatically. So that's nice. Now, what about cargo? What was I doing here? So let's see if cargo works. I have an idea that it's probably not installed. It is installed. And what is cargo? Is basically it's like pip in Python. Okay. So, but you have to create a project. That's what I'm screwing up on. So, cargo new hello. I see. Okay. So that's good to know. Let's document that as well. And we can say, how do I compile? So the issue here, I think, is that in the real world, you're not going to just play around with a compiler. You're probably not building anything useful in a company. You're going to have to use a package manager, just period, for any language. And so you would want to actually create all of your projects with a package management system. So in some sense, sure, it's as a one-off to kind of mess around. You can use the Rust compiler, but typically, I believe almost every developer would use something like Cargo. So let's say, how do I use Cargo? Great question. So now we can put, first make sure you have it. Do you have it? Okay. And then we go here. We put in Cargo. And then next, what we do is we need to make a new directory and cd into it. So this is pretty classic with most compilers and or tools that build things like package management tools. And so we'll say cargo new, hello cargo, and then and you could even be fancy and do the Unix command and. So basically, if this command was successful, then go ahead and go into this directory. There we go, cargo new hello cargo, and then put that in there. Perfect. So let's do that. But let's change it a little bit. Let's call this hello function. All right, we'll leave the documentation of where it is, but right here, because I think this was probably episode 2. Do this. But episode 3, I'll say, make a function. So step 1 would be that I would say cargo, I would run this cargo command. So we'll say this, we'll say cargo, we'll say hello func, and then we'll cd into that. There we go. So let's run this command inside of my GitHub code spaces. There we go. Cargo new. Excellent. So it says created binary application. So this is a beautiful thing versus scripting languages, which are really a train wreck. And in fact, you kind of, I'll do a slight rant here about scripting languages. You know what I think the real issue with Python, Ruby, and other scripting languages, which obviously I use, is that they were not developed to have a production first mindset. And the newer languages are, right? So this is obvious. You're building a production tool that has, an application like from the get-go. So their benefit is from learning about the problems from other languages. So now that I've got that, what I'll do is I'll CP the one above here. So this is something you can do in Unix. You can say, hey, go up one level and give me that other code and just put it right here, right? And then I can just even delete this compiled binary. I don't need it anymore. So and we can even delete this. We don't need it. There we go. Okay, so we got the hello func directory, and look, it created the cargo 2ML. No, we don't care about that. So it's cargo 2ML, and so it says, okay, look, we're creating something, blah, 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 blah. And then inside of here is the main.rs, right? So here's a function. So what I can do is actually just take this out. So I'm going to copy this and I'm going to paste it into my main function here. And then I'm going to delete this one as well. So now we're basically cleaning things up here. Great. So now I have these two functions, and I guess I can even add some documentation and say, function one. I think I'm just almost every language supports comments as hashes. I will find out. Function two. I actually don't know, but we'll find out. So now all you have to do is we have this, you just say cargo build. Okay, that's kind of cool. It's less work. It really is less work. We just say cargo build, aha. So it doesn't like, so I was wrong. So can you do this? Okay. So I didn't write comments correctly, which is cool. The compiler tells us. The compiler is very nice. It says, okay, now you're good. And so we'll put that into the documentation. We'll just say here, and then go this cargo build. I'll put some code in there like this. Put some code in source in src main like this, and I can even put a little snippet. Rust. Yeah, so far, it's quite pleasant. I'm liking Rust. I get the appeal now. It's not too bad. Not too bad at all. I could definitely see myself wanting to code in Rust. Okay, so we got that compiled, finished, perfect. And now I can say cargo run. Oh, okay, let's do this. So we'll say cargo run. There we go. I ran our code. Not bad. So I was able to, I don't know if I even went over this before, but I relearned it if I didn't know it before. I'm going to go back to functions now. And we see here it says we define a function by entering this command. Okay, that makes sense. Because this is in the program, we can call it. That makes sense. Now, in terms of parameters, this is probably one of the most important parts of writing a function is almost all functions to be useful need to be able to accept a parameter. It's not always the case you have to accept a parameter, but at some point you're going to need to accept parameters. And so technically the concrete values are called arguments, but in casual conversation, people tend to use the word parameter and argument interchangeably. which is, yeah, I do that. So here we go. So we say right here, this thing, I believe, so the type of X is specified as I32. Okay, so you declare the type inside, and then we set our parameter. Okay, that's useful. And I guess we don't need our comments. I mean, I guess if I want to be lazy, I can just do this. There we go. Okay, so we got our new function here, which is another function. It takes an X, and then it has I32 as the type, and then this function is able to actually pass in that argument into the function, which then in return prints that statement. Makes sense. We'll go ahead and say cargo build, and then we'll say cargo run. It says value is 5. Not bad. I like it. Okay, what else can we learn here? So in function signatures, you must declare the type of each parameter. This is a deliberate decision. Requiring type annotations means the compiler almost never needs you to use them elsewhere to figure out what you mean. So when defining multiple parameters, separate the parameter declarations with commas like this. I see. So what we would do is have a second argument called unit label, and then we would declare what it is. In this case, it's a char. Okay, I like it. Let's go ahead and do that. And we'll paste this in. Okay. And then we'll paste this in. Yeah, very cool tutorial. I like this. So if I reread the code here, so we have the first argument, which is value I32, second unit label, which is a char. And so we are able to pass in two things now. And the first thing that we pass in is a 5. And the second thing that we pass in is actually this, this character. And so we can say the measurement is, and then we do string substitution, which I like how they do string substitution here. Very clean and neat. Is very, looks like Python actually. So, or even C# has a similar style. Okay, let's go ahead and do cargo build. There we go. And now let's do cargo run. There we go. The measurement is 5H. Not bad. So statements and expressions. So the functions are going to be made up of a series of statements optionally ending in an expression. And so because Rust is an expression-based language, there's an important distinction to understand. Statements are instructions. So we've already used statements and expressions. So by creating a variable and assigning a value with it, with the let6. Okay, so this looks identical to Swift, which is kind of cool. And so we see this. Here's our function let6, let y equals 6. Function definitions are also statements. Statements do not return values. Therefore, you cannot assign a let to another variable. Let this, when you run the program, let y, I see. So the let's y equals 6 statement doesn't return a value, so there isn't anything to bind from. This is different than languages like C and Ruby. Okay, so now we'll get into something a little bit more meaty. So we've got a let here, which has got brackets. We have another let inside. So x is equal to 3, x plus 1. We print it, and that's the expression. And the value gets bound to y. So all of this gets wrapped up in here. Okay, now, so this is interesting, but I'm more interested in functions with return values. I want to know how to return things inside of here. So I guess what I can do is maybe swap out the code I have already for this. So let's see, functions can return values to the code that calls them. We don't name the return values, but we must declare their type after an arrow. The value is synonymous with the value of the final expression. You can return early with the return keyword and a value. Most functions return the last expression implicitly. So this is nice to know. So this is different than other languages. Like Python, you have to do explicit return, but in Erlang, you don't. And I think F# as well. So here's an example of a function that returns a value. So in this case, oh, I see. So it returns back a 5 because it's the last statement. So that's neat. That's neat to know. So basically, the last line is what gets returned. So let's do that. So we can even do a note here that says, basically, note that the 5 is returned perfect. And if we go ahead and run this, we say cargo build, cargo run. There we go. We're able to actually return this. If I want to change it, and I say not 5, here, not 5, and I say not 5, it should return back 10 because it's again the last line. There you go. Okay, so I'm excited. I like this. I've been able to get a little bit deeper into Rust, and I have to admit, I'm very impressed at how smooth the language is and how intuitive it is to somebody that's kind of a Unixy type person. And I definitely, beyond just doing these demos, I could see myself wanting to get pretty deep into it. Actually, it's got me hooked. So I'm going to check in this code here. So let's go ahead and save all this stuff, commit it. And then I can also do this. We can say, go at the level, git status, git add, and commit this, add new code. Well, I probably checked in some garbage, but I'm a newbie, so I'll figure it out. Let's see here. Git push, git pull. Let's go ahead and do that. That looks good. And then git push. So yeah, I think I'm checking in like binaries and all kinds of bad stuff, but I'm okay with that. So yeah, I'm going to not share the screen more and just say, yeah, so we wrapped up functions today, and I'm not in a hurry at all. I'm going to keep going and move through the official documentation, just try it out and give you my perspective as kind of a newbie, and hopefully that will help other people that are learning Rust. So see you next week.